Hi and welcome to video 7 on my video series on definite integration in the area below curves. You'll notice now that I've split these examples up as they've taken me a while. So I did example 9 in the previous video and I'm going to do example 10 in this video. So example 10 is to calculate the area enclosed by the function y equals 2 sine x, the y-axis, and the terminals y equals -2 and 2. Now example 10 and example 11 are both periodic, so I might put these two together. The first thing I'm going to do again is plot this function and have a look at the shape of the function. Now this time let's assume it's a tech-free, or at least initially, and have a talk about how we can do this, maybe with a decent axis. Okay, so we want from -2 to 2, and 2 sine x, we know it starts here, we know it goes up to 2, but we know it has a period of 2 pi, which equals approximately 6.28. And so 6.28 out here somewhere, so we've got 4, 6, it goes to here, 6.28. And in fact, we can have a look at some of the other elements of it. That is, for example, that it does quarter of a period in half pi, which is our 90 degrees, and half pi is 1.57. So it's going to go up to 2, and then just start coming back down, like that. I might just stop it there and just draw a little dotted line, and it's going to come down to -2 and just start going down. So I really strongly urge you to start considering getting used to these graphs and seeing if you can do some of this tech-free. Probably this question would be in a tech-active paper, but you never really know, and it's worth making sure that you can do the simple trig functions without too much of an issue. So let's do the area calculation. We can see that it crosses at 0. We can see this is a negative area and this is a positive area. So I'm going to do area equals area 1 plus area 2, but area 1 is negative, so I've got to make it -2, then make it positive, absolute value, that area 1. And so, yeah, another approach I could have is to write this as an absolute value sign, and this one as an absolute value sign, which guarantees that you get it right. And of course, now I can put in my integrals. So I get the integral from 0 to -2 of 2 sine x dx, and that's an absolute value, plus the absolute value of the integral from 2 to 0 of 2 sine x dx there. And this, of course, is equal to 2 cos x between 0 and -2, but of course 2 cos x is a negative value. Cos derives to give negative sign, and then plus, and I have to make sure I've got my absolute value signs there, the absolute value of -2 cos x between 2 and 0. And so this comes out as the absolute value of -2. In fact, I'm going to take -2, no I won't, because I want absolute values. So I'll take -2 out here, and then I get cos of 0 minus cos of -2, and then I'm absolute value, adding to that the absolute value of -2, and then I get cos of 2 minus cos of 0, and the absolute value there. Now I know that cos of 0 is 1, but I don't know cos of -2 or 2. So what I'm going to do is just do this evaluation in the calculator now. So we'll assume we're back to tech active. If we were tech free, you'd pretty much be right to leave it there. Remember, we know that cos is an odd function, so we can change cos of -2 to negative cos of 2. So we could write this down as the absolute value of -2 of 1 minus plus cos of 2, and then plus the absolute value of -2 of just cos of 2 minus 1. And of course, then we can take out the absolute value signs. We get 2 outside of 1 plus cos 2 plus, now cos 2 minus 1, that's our problem. But cos of 2 is going to be less than -1, or less than 1, because 1 is the peak that we get to in a normal cosine function. So if 1 is the peak, then cos 2 must be slightly less than that 1 in the standard cos function. So therefore, this times by a negative number will be positive, so that doesn't apply. We get plus -2 cos 2, and then plus 2. We expand, we get 2 plus 2 cos 2 minus 2 cos 2 plus 2, and that's equal to 4 units squared. So that would actually be quite a nice question because we didn't have to rely on the calculator even though I thought we were heading there. But that works out quite nicely. Again, you'll notice a few little things. We do start with the diagram after the interpretation, and we responded really to what the calculator situation was. If you got to here in a tech active exam, you'd just be throwing that straight in your calculator. You just have to be really careful about where you put numbers and getting your brackets right. In example 11, you're told a couple of coordinates the curve passes through, and then you're asked to find the area of a region enclosed by the curve between x equals 0 and 1. Now this is a really common example where you're asked to develop a function and then use it to find an area. This type of thing, in particular with external exams where there's more content covered, could really come up and you should make sure that you can do. And it involves going back and doing some work on the Year 11 content on trig functions, exponential functions, even polynomials. So running through this question first of all, it passes through 0, 1 and 3, 3. So we've got y equals a plus b sine of pi x on 2. Now 0, 1 and 3, 3 might represent important points, but we don't know. We don't know whether one of them is a peak or whether they're in the middle of the curve. So our best bet here is to take some time instead and consider them to be just points, and we can get some simultaneous equations that we can solve. So we get at x equals 0, y equals 1, which leads to 1 equals a plus b sine of 0. Of course, sine of 0 is 0, so therefore a is equal to 1. So that's the first thing. At x equals 0, we have a center of equilibrium, and so our a is 1. A is kind of like the d, it's the how much it's been raised. So we've got our a, and we also know that at x equals 3, y equals 3, leading to 3 equals 1 plus b times sine of 3x on, 3 pi on 2. Now 3 pi on 2 is a rotation and a half around a unit circle. So it's here. And sine starts at 0, goes to 1, goes to 0, and then goes to negative 1. So at that point, sine is negative 1. That gives us 3 equals 1 minus b. And therefore, b is equal to 1 minus 3, which is negative 2. And so we get y equals 1 minus 2 sine pi x on 2, and we're solving between 0 and 1. Now it's important here to just take a moment to think about what the shape of this graph will be. And so again, I've done the hard work, and now I just need to draw the graph between 0 and 1. So this graph, it's still a sine graph. It's got a shift of 1, that's the center of equilibrium, and it's got an amplitude of 2, but it's negative, so it goes down first. So it's going to go like that. We want to find the area before 1, but there's an x-intercept in there that might be a problem. So you have to be a little bit careful of that. So first, let's just explore to see if 1 will have an effect. Because if this is, say, 5, then that's fairly good evidence that it probably won't, and we can play with it from there. But we know that this hasn't got a change of, it's got a b value. So the b value equals pi on 2, which means therefore that the t value is equal to 2 pi on 2, which equals 4. So that tells us that it gets to here at 4, gets to here at 2, and it gets to there at 1, which means we're finding this area and this area here. And that means that we need to find this point of intersection, which is important. So let's go about finding this point of intersection. Intersection at y equals 0, that's the x-intercept. So 0 is equal to 1 minus 2 sine pi x on 2, and we subtract 1 from both sides, giving us negative 1 equals negative 2 sine pi x on 2. We divide by negative 2 and we get a half equals sine pi x on 2. And that of course means that pi x on 2 equals sine inverse of a half. And that of course means that pi x on 2, sine inverse of a half is pi on 6. It's also 5 pi on 6, and there's plenty more and some negative ones, but we only care about the first instance, which is there. So that means that x is equal to pi on 6 divided by pi on 2, which is kind of like the same as 2 over 6, the way it works out. Pi on 6 times 2 on pi, and that's equal to a third. So we've got our split of the third. And so now our integral is going to look like this. The integral, so the area, let's set this up first. We've got a positive area here. We've got a negative area here. So the area total will be equal to the absolute value of the integral between pi, between 1/3 and 0 of 1 minus 2 sine pi x on 2 plus, and so that should have a dx there, let's pretend it's there, the integral between 1 and 1/3 of 1 minus 2 sine pi x on 2 dx. Now this is a bit of a long-winded question, so I'm going to put this on speed, and I won't commentate until I get to the end where I talk about my answer, and you can watch it as I progress and slow it down if you wish. And so you've just seen me do the calculation as well as my calculation, and there's my exact value, and I've verified in a calculator. It's a bit of a long process, but you're probably going to get some questions that are long processes, so I suggest that you practice that and ask questions on this if you need to. Anyway, here is the stuff that you should be able to do as part of this, but doing it for exact values and decimals as needed. All the best.